Okay. I tested positive for COVID, so I'm probably going to be home for the next few classes. I'll probably be back next Wednesday. I'm going to try out making some videos. I'll post in my Google Classroom. I'll also post the notes, and we'll just spend the next couple classes going through these. So it'll probably make like a 20-minute video of me doing the parts that I would do up at the board, and then you can you can pause it wherever you want and fill in the examples that I don't do. That's my plan right now. I'll give you an update at the beginning of each video as we start going forward. The next unit we're going to do is Unit 7. We're going to skip Unit 6 because there's only like one key element from it that is like useful in areas other than geometry. So we'll talk about that when I get back there, and we'll do any SAT questions that relate to what would be brought up in Unit 6. But for now, we're going to start on Unit 7, which is on similar polygons, which is useful all over the place. So we've talked about congruent polygons before. Something's congruent if all the angles and all of the sides are exactly the same. For similar figures, two figures are said to be similar if all of their angles are the same. So it's just a shape that we've taken and like dilated or scaled. That was the OpenSCAD command. So if the angles are congruent and their side lengths are different, we would say proportional in this case because all of the side lengths will scale with the same scale factor. When we gave the scale command, we gave it a scale factor. Are proportional. Okay. So this is an example. So this is just a scaled version of the other one. Looks like it got smaller, but you can see that each of the angles are the same. They've labeled that with these arcs here. And then the sides are proportional given this proportion. So this side corresponds to this one. There's sort of like a 3-to-1 correspondence. Like 18 is 6 times 3, 15 is 5 times 3, 12 is 4 times 3, and 21 is 7 times 3. So if you set up a ratio, A over B would be 15 over WX is 5. You're going to get 15 over 5 is equal to B over C. It'd be like 12 over 4. All of those will equal each other. 15 over 5 is 3, 12 over 4 is 3. So the scale factor is constant. Okay, so the way I do that for one of these where it's asking me to like write these statements, I can look at the order so the angles are given in the correct order. So I'll say angle F is congruent to angle J, angle G is congruent to angle K, angle H is congruent to angle L. Okay. And then we've also got to write a corresponding sides, like a proportion statement. So I would say that, again, I can look at these things. So I see FG is first. So FG over JK will be one of the proportions because FG corresponds to JK. Okay. That proportion will equal GH over KL. GH over KL, which will equal FH over JL. Okay. You can sort of look at the diagram for that as well. You can sort of see GH and LK correspond, so GH and LK are the same. The hypotenuse FH and JL, those should go together, or FG and, FH and JL go together. Those are the hypotenuses, and then the long leg FG and JK also go together. Again, they're proportional. So if you plugged in the numbers, you get that those things all equal each other. Okay. Let's continue on. So we're going to think back to dilations. We need a scale factor. So that's the number that you'd put in the scale command if you were changing the size of something. In OpenSCAD, we gave it a scale factor for X, Y, and Z because we were scaling the lengths differently depending on which dimension they were in. For this, we're just going to use the same scale factor for all of them. So it'd be like scale 333 or something like that. Okay, going from ABC to XYZ, that's asking us what would we have to put as our scale factor on this to turn it into this. So what do we have to multiply each side length by to get the new side length? For us, this line is labeled, so AB and XY are both labeled. Those are the two that correspond to each other. Again, AB and XY fall in the same place, or the first two letters. So these are corresponding sides. They'll be proportional. We got to think, what do we do to 6 to turn it into 3? What do we multiply 6 by to get it to be 3? Our scale factor would be 1/2. So you multiply 6 by 1/2, that gets you 3. Going from XYZ to ABC, this one might be a little easier. Think about if we had this shape, what do we multiply by? To get that shape, we'd multiply by 2. Okay. For these ones, the way we solve it is we look at them, and if it's a triangle and we know, 2 angles are the same, we know that this one has to be the same then, because the angles all add up to 180, and then we just look for correspondence here. So I'll do that with this one. I'll leave this one for you. So I'm just going to label this as 3 arcs here. Now, I know that these are similar because this plus this have to equal 180, right? And I know this plus this also have to equal 180. Since these two are the same and these two are the same, that means that this one also has to be the same. Okay, and now I'll set up some proportions. So my line that goes between my 3 arc angle and my 1 arc angle is 12 on this, and it's 15 on this. So I'll say 12 over 15, okay? And then, let's see, between my 3 arcs and my 2 arcs, 3 arcs and 2 arcs, I've got 9.2 and 11.5, 9.2, 11.5, okay. And then my 2 arcs and my 1 arc, I got 10 and 12.5. It was 10 over 12.5. Okay, 12 over 15, that's the same as 4 over 5. 9.2 over 11.5. Let me use a calculator. Yeah, phone. Pretty sure that's going to be, yeah. So 4 over 5 is the same as 0.8. So this would also be 4 over 5. That is equal to 4 over 5. Out of your calculator, what it'll say is 0.8 equals 0.8, which equals 0.8. All right. The way you'd say that these are not similar is if you did this proportion and it didn't work out. So you should get that for this example here. I'm going to leave that one for you to do on your own. Think of what this angle has to be for it to be a quadrilateral, like what angle does it make sense to be, and then try to set up the proportionality thing. Okay. For it to be similar, all 3 of these proportionality statements have to be equal. Okay. What you'll most often see this in is figuring out an unknown side length. So you'll see this as an SAT question in some form. It usually won't just be a simple diagram like that. They'll be connected in some other way. But you will have to use similar figures to figure things out. So it says that these 2 things are similar. Our angles here, it looks like, okay, so it looks like a parallelogram. We got 4 corresponds to 8, and then 3 corresponds to x. So my proportionality statement for that, I could say 4 over 8 is equal to 3 over x. Because these 2 sides correspond, so they go on a fraction. These 2 sides correspond, so they go to fraction. You got to make sure that you're always taking the numbers from, the top numbers from the same figure. So you can see here, all of my top numbers are from this figure. All of my bottom numbers are from this figure. That's one thing to watch out for. All right, once I've got it set up like this, it's you do cross multiplication. You can also multiply both sides by x and by 8 if you wanted. This is like an algebra 1 trick. So you do cross multiplication. So 4 times x is equal to 3 times 8, or 4x equals 24, or x equals 6. I'll leave that one for you. Let's see what else we got. X and Y. Yeah, so there's going to be a lot more of these. Again, this is a fairly important skill going forward. It's got, you use this outside of geometry in later math and in a lot of engineering concepts, so it's good to practice. Let's see, 12, 9, okay, so it looks like FD and YZ correspond to each other. So FD and YZ are in the same spot in this statement. That means they correspond. So I can say 10 over X. So I'm saying my top numbers are coming from this one, bottom numbers are from this one. You could switch it if you wanted, you just got to be consistent. Okay, that's going to equal, let's see, what does WY correspond to? So WY are my second two letters. Second two letters here are C and D. So WY and C and D are corresponding. So that means I get 6 over 9 there. And then that means that this 12 will go with the 3y minus 1. 3y minus 1 over 12. And I got to do this proportion. I'm going to separate it into two different ones just because that'll be like easier to look at. If I've got two equal signs, I can just make an equation that's like these two equal each other, and then I can make a separate equation that says these two equal each other. So I'll say 10 over x is equal to 6 over 9. And then I do my cross multiplication there. To solve a proportion, I get 90 is equal to 6x, or x is equal to 15. For this one, I'll just say 6 over 9 is equal to 3y minus 1. Again, to solve my proportion, I get 6 times 12 is 72. And then I'll write this out as 9 times 3y minus 1. So 72 is equal to 21y minus 9. Add 9 to both sides. 81 equals 21y. Oh no, this is 27, sorry. Okay, then divide by 27. Y equals 3. Okay. So, again, same sort of deal. Figure out which sides correspond to each other. Then you can set up a proportion like that. Again, the big thing about similar polygons is that their sides are proportional. Okay. For number 9, I think you can do that on your own. Oh no, that's a good one to do as part of the notes. So I'll do number 9. It says find the scale factor and find the two perimeters. What do you notice? Okay, so our scale factor is what we have to do to multiply like one to get the other, right? We can write that just as a number, like we can say 1 to 2, or like 2 to 1, or like 1/2 or 2. The way we wrote it earlier on, we said 1/2 or 2. We could also write this as ABC to XYZ. That is a 2. Let's see. Yeah, we scale it by 1/2. We scale this one by 2. We could also write this as a 2 to 1. Or a 1 to 2. Okay. Anyway, on to number 9. To find the scale factor, what I'll do is I'm going to say, what do I have to do to get from 5 to 15? So I'm going to say my scale factor from W, X, Y, Z to, what did I say? W, X, Y, Z. So that'd be A, B, C, D to A, B, C, D is equal to 3. Okay, so going from this one to this one, I have to multiply everything by 3. 5 times 3 is 15. 4 times 3 is 12. Yeah. Now let's find the perimeter. So perimeter, I'll say that this is figure 1, or figure 2. This is figure 1. Okay. So the perimeter for figure 1 is going to equal 15 plus 12 plus 21 plus 18. So what would that get us? 12, 22, 30, 66, I think. Yeah, 66. And then P2 equals 22. All right. So what I see again is that the two perimeters are related by that same scale factor. So 5 plus 4 plus 7 plus 6 gets us 22. If I multiply 22 by 3, I get 66. So I'll say perimeter are related by scale factor. Okay, great. Let's move on here. Again, we're going to go for about 20 minutes and then call it. We're about 15 minutes in. Two polygons are similar. The ratio between their parameters is the same as the ratio between their sides. We could also say ratio or scale factor. Okay. This one you can do on your own. This one you can do on your own. It's asking you to do, like, for this one you're going to have to use similar figures to do this. So we see that the 4, like these 4 tick marks means that this length is the same as this length, because these both have 4 tick marks. These 3 mean that this length is the same as this one. And then it says that they're similar. So we know that the ratio is like 4 to 3. If this one's 4, we'd label this one 4, we'd label this one 3. Then you can look at, okay, so 4 goes to 3, then 8 should go to 6, so that'd be 6, and then 6 would go to some other number, so you put that there, find the parameters. Okay, for the next one, we're going to think about like square, so I'll do that one 12, 13, and then we'll call it a day. That'll be good. If polygons are similar and the scale factor between their sides is k, the scale factor between their areas is, I'm just going to write this down and then we'll go through why it is k squared. Okay, so let's just do this by an example. So I'm going to draw out a square because that's something that we know like the area of very easily. All right, I'm going to say that all of the sides are 1 unit long. I'm going to draw a different square now. It's got k on a side. Okay. Don't worry about what k represents. It could represent any number. All right. So let's say that k represents 3. If k represented 3, then our area of this would be k squared, or 9, so 3 squared. And our factor, our area of this one equals 1, because we do 1 times 1. Okay, 1. Area for this one is equal to k times k, or k squared. So 3 squared is 9. We can also just represent this as k squared. Yeah. Essentially, if you double the length of something, and it's a polygon, if you double all the lengths, you're going to get 4 times the area. If you do that with a cube, like you increase all the side lengths by 2, then your scale factor is going to go up by, k cubed. That's where like the terms squared and cube come in handy with scale factors. All right, I'm going to call it there. I think that should be good. So for class, I want you to sort of go through, fill in the things that I've written down, and then use the rest of the time to go through the problems that I did not do. So you should be able to do number 2. This one right here, number 5, number 7, number 8. Okay, this will be a good one for you to see this relationship actually worked out. So then do 12 and 13, and that'll be good. Yeah, good luck. If you've got any questions, feel free to email them to me, and I'll give you another update in the video on Friday. So